So for my project, I wanted to talk about mathematics and society. Specifically, how the development of mathematics and the motivations behind its developments is different depending on the society and time in which the developments take place, because mathematicians are people. They're influenced by the cultural values that the society they live in hold and the technologies present. So first, I want to talk about ancient Egypt. So Egypt was a large centralized state, and it needed a lot of administrative ability. So to do this, they appointed scribes to carry out mathematics, to carry out a lot of official duties that required literacy and mathematical competency. So a lot of the mathematics that occurred in ancient Egypt looked a lot like this. Typical problem: divide 10 by 6. For ancient Egyptians, this math problem would be given as something practical. Divide 10 loaves of bread between 6 men. The answer you get is 1/2 plus 1/10, using only unit fractions, as Egyptians would have done. To check the answer, you simply do the doubling process shown below. You have the first line, then the second line, the fourth line, or the third line and the fourth line. Each one doubles in the left-hand column and in the right-hand column. You take the numbers in the left-hand column that add up to 10. You use the corresponding numbers in the right-hand column, add those together to check your answer, and indeed you do get 10 and 6. And so I think this problem is important because, firstly, the way it's given in the Rhind Papyrus to the scribes is as a practical example, something that they would have to do in day-to-day life, and I think that shows how Egyptian math was really motivated by practical necessity. And secondly, I think the use of unit fractions is intuitive and easily applicable to real life. You can just divide those loaves of bread into 1/2 and 1/10. 5 go in 1/2, and then 1 goes into 1/10, and then you can distribute bread easier than you could if you were trying to divide them all into 3/5. So moving on to ancient Greece, you get still using practical math. People like merchants and navigators still need to use practical math to get along in their professions. However, the structure of Greece is different. The terrain divides the entire region into different city-states instead of one big centralized state. That means you get different governmental structure, and that results in different societal values. So instead of scribes performing math out of practical necessity, what you end up with is a bunch of city-states where people are encouraged to debate, to form logical arguments. And you'll note that the intellectual community is made up mostly of philosophers. So philosophers were primarily the mathematicians of the day, and you can see this in their mathematics. And right here you just have a diagram of the construction for the proof proposition 116 out of Euclid's The Elements, basically saying that if you extend the side of one triangle here, CD, that the external angle ACD is going to be greater than either of the interior and opposite angles. And basically you prove this just by making this construction and seeing that triangle BAE is congruent with ECF, and therefore ECF, that angle is equal to BAE, and then since ECF is part of ECD, the whole of this angle is going to be greater than BAE, and you've proven the proposition. And the thing about this is it's really rigorous. It's rigorous and it's very logically sound. The construction is more than you would need to convince most people, since this is kind of an intuitive thing. However, in Greece, it kind of shows this type of problem. These very formal constructed proofs show that it's the methods and the construction of logical argumentation that's much more valuable than the practical necessity of the math you're practicing. I mean, obviously these proofs are not very practical or useful in day-to-day life. And so you can see that in ancient Greece you have this detachment of mathematics from physical reality, as you did in Egypt, and instead it's moved into sort of an abstract realm where the use of mathematics as sort of a logical thought exercise is more important. Then, moving on to early modern Europe, you see that the introduction of new technology then influences culture and influences mathematics subsequently. So the introduction of the printing press in about 1450 kind of revolutionizes early modern Europe. Creates an entirely new academic society, because you all of a sudden have this large, easy way to disseminate information. And so a good example of seeing this is with L'Hopital in the 17th century. So L'Hopital decides he wants to publish a calculus textbook because he reads about calculus in a journal. And after being tutored, he decides he's learned enough and he wants to publish this textbook. And I think this is important because L'Hopital was a nobleman. He was a French nobleman and he was independently wealthy. And firstly, you can see how printing affects his life because he learns about calculus from a printed journal. And that kind of shows the power of expanding mathematics and part of the intellectual community with this new printed technology. And then secondly, I think that the fact that he wants to print a textbook shows how the establishment of an academic community as a result of the introduction of printing technology is important because he doesn't need to print a textbook to make a living as an academic. He's independently wealthy. He can do what he wants. The reason he wants to print this textbook is because he wants prestige within the academic community and to advance the scientific field that mathematics has then become in early modern Europe because of this new technology. And I think just as a closing note, it's still like this today. Society is influencing math right now, and new technology is influencing math throughout the modern era. For instance, the invention of computers has kind of revolutionized mathematics and the way we do them, in that it gives us tools to do more calculations and to make better visualizations for very abstract concepts in complicated mathematics, such as fractals. The fractals that we were looking at, for instance, in lecture just a week ago were only possible because they were computer generated. And so I think, just in closing, that looking at these three societies, you can see through the mathematical problems that they did and through the example of just one person and how they were impacted by the technology of the time, that mathematics is heavily dependent on society. Mathematicians are people, and that we should be conscious of this, that mathematics is very dependent on the culture it comes from and the time and the technological limitations of the day.